Hola, mis amigos, and welcome to Party Wordplay. So we've kind of done some high-level overview stuff of object-oriented programming, which we're going to review, and then we're going to try to get our hands dirty and maybe put some of this stuff in practice together and hopefully get a little bit more confident in syntax in JavaScript and TypeScript for object-oriented programming. So, quick review. Can I get a brave volunteer to give me a definition of class? What's a class?
A group of people with an instructor.
Hey! I like it.
A class is a blueprint for an object.
Blueprint for an object. So that, of course, begs the question: what's an object?
We can't see your screen.
Oh, come on.
An object is anything.
Yes, be more specific.
They're containers that send messages to each other and have properties.
Beautiful. So in our kind of like biology metaphor, these are all cells. And the cells have their own stuff going on inside all of them, and they all got their own nucleus. I guess that's kind of like a constructor. And some of them have properties and methods and whatever else. But the way they interact with each other is to send each other messages. They can also do stuff like kind of like be contained inside of each other. So like this sort of fractals, zooms in, zooms out. So like an object can have another object as a property, for example. But otherwise, we try to keep all of the state wrapped up inside of this object, and then rather than working directly with the state, we call methods. That's how we can get state out. That's how we can change state. That's how we do all that sort of stuff. Okay, that's classes and objects. Another vocab word. What's a constructor?
A constructor is a method, and you pass into it the properties needed to get the object in a workable state.
100%. So, important thing to note on that, it actually doesn't need to be every single property that's on the object, just enough to get it legal. And what we mean by legal is that we can call the methods and stuff on it, and we're not going to get a runtime error because something doesn't exist. All right. How do we call an instructor? Come on. How do we call on Zoom? How do you call a constructor?
With the new keyword.
You got it. So constructors are invoked with new. And then next question is properties and methods. What can we compare those to?
Like functions, right?
Functions and
Oh, the parentheses. Those guys.
Values?
variables.
Variables.
So in like procedural and functional programming, we have variables and functions. And object-oriented programming, we have properties and methods. We can also, especially in JavaScript, use variables and functions and stuff too. But these are like big ideas in object-oriented programming. Let's see. A little bit trickier. What does the this keyword refer to?
Class that you're currently in.
the
Yeah.
instance that you're currently in. I love it. So if I have a cookie cutter and I made some cookies with it, this is how I'm going to reference a particular cookie, the one that is like the object that I'm in right now. And then last one. What's an interface?
Interface is like a template for classes.
Yeah, very nice. So like kind of like type safety. So the same way that we use types to constrain what kinds of values a variable can have, we can use interfaces to not really constrain, to guarantee that an object will have certain properties and methods. So the reason for that is that since that's kind of like a contract, we can, if we're using something that's using an object, then we can program to an interface. And if other things are using that interface, we have some confidence that they all do it the same way. If we change something on the interface, we get very helpful errors telling us every place that the contract has been broken, so we can go fix it. But there we go. All right, so that's our vocab. Let's start getting dirty with it. Let's pull up triangle. That's a pretty good one to start with. So take a second, clone this down. If you've already been working on it, leave that one alone. Let's start fresh. So when you pull it down, you're going to need to npm install. And then once you've done that, you're going to want to run your tests. And hopefully we see 19 failing tests. Woo! All right, take a minute, get that far.
Okay, so dumb question. If we've already forked it and done it, how would we start from scratch?
Don't fork it. Just clone it directly.
Just clone it to a new, okay. Thank you.
I know those npm installs can take forever. I'll be right back. All right, give me a. Hang on. Give me a thumbs up if you're ready to go. Mostly thumbs ups. Beautiful. Andy, what do you need?
It's just installing everything. All right, I'm good.
All right. Cool. So, stay on my platform.
Mine's stuck halfway, but y'all
Uh-oh.
can go on. I'll just wait.
We'll go slow. So,
No one gets left behind.
no one gets left behind. So first thing that we can do that'll help us out a little bit is if you go over to the test file. Let's narrow this down a little bit. So we could say that I want these to be like the only things that are running. And then do, see, do I already have a watch command? Nope. So I can do npm test -- space -- watch all with a capital A. Oop, with a capital A. All right, now I got a failing test. So, very first thing that it tries to do is assert that an is equilateral property is true if all three of the things that you pass into the triangle are the same. All right, so this point, I kind of want to pause and wrap my head around the problem. So part of the object-oriented thought process is what kind of state can this have? So help me out with that. What kind of state can a triangle have?
3 equal sides all greater than 0.
Okay,
Or
so
3 sides greater than 0.
all right, so you're in the ballpark. So yeah, so 3 sides. Each of those is a piece of state. So it's like side 1, side 2, side 3, and all of those are more than 0. So everything else about this triangle, we can derive from that. So it would say that like whether or not it's isosceles or whatever. So those 3 things, that's the state, and that's part of what we're abstracting away. So if I look at my actual starter code, I know that I'm going to have 3 sides. Now, I've seen you collectively do this a couple different ways. I think they're both fine. So one way that y'all have been doing this is to declare the properties as like side 1 is a number, side 2 and 3 are numbers, and do it that way. I've also seen folks doing sides as an array of numbers. That's like technically a little less correct because you could have 2 numbers there or 4 numbers, which isn't legal. I've seen some of you doing tuples to get around that, which is also fine. I think there's good arguments to be made for all of these. But I'm going to say that it's got those three pieces of state. So if I look at how this code is being called, remember new calls the constructor. That's what we learned from, where is it? That's what we learned here. We call the constructor method with new. So that's instantiating an object with new, and it's passing in these three numbers. So we could make a constructor here that has like number side 1, which is a number, side 2, which is a number, and side 3, which is a number. And then to make all these like angry red lines go away, that's what we're constructing an object with. They're not part of the actual state of the object until what? Who can tell me?
Until we use the this keyword?
Until we use the this keyword to actually set the state. Come on. So over here, we want to say this dot side 1 equals side 1. Like that. Now we've correctly instantiated this object. So, a couple things. This is probably like in the power law, 80%, 20%. 80% of constructors basically look like this. They take in arguments and then they just assign those arguments to some state on the object. We could and probably should also like make sure that all these are valid. So like for example, none of these can be negative. They have to be, all have to be more than 0. So maybe we say like if side 1 is less than or equal to 0, or side 2 is less than or equal to 0, or if side 3 is less than or equal to 0, then maybe we need to throw a new error. But that's what's meant by the constructor needs to put the object in a valid state. If this thing could call a new triangle with -2, 2, 2, then that's not a valid triangle. The constructor's job is to catch that and like do stuff like this. And then otherwise just set the state. Questions so far?
Can you explain again why we need lines 2 through 4?
Yes.
Because does, I guess I'm confused. I think the line 6 does the same thing, kind of?
Not quite. So this is like a totally normal thing to be confused about. This is just some function. It doesn't actually do anything with the object that we're making. And it takes in these arguments here, but it doesn't actually make them part of the state of the object until we assign them here. And part of the point of doing this is type checking them. We're saying that any object of type triangle is going to have 3 sides and all of them are numbers. So if I accidentally tried to assign this dot side 1 equals 1, it catches that and lets me know that I did that wrong.
Okay, so it doesn't check the type within just that function. It has to be outside of the scope, I guess?
It needs to be part of the objects that you're making.
Part of the objects, okay.
Yeah. Because, like, remember, this is the blueprint. The actual triangles we make are like, cute triangle is new triangle 111. Beefy triangle is 100, 100, 100. Goofy triangle is 150. So we're using this blueprint to make all of these different kinds of triangles. Each one of them has their own state. So cute triangle gets initialized with all three of those being 1. Beefy triangle gets initialized with all three of those being 100. Goofy triangle gets initialized with this being 1, this being 100, this being 50. And since there's state, they can change too. I can do cute triangle dot side 1 equals 50. That's allowed. Because it's state. Remember, state is something that can change over time.
Kyle, I have a quick question for you. Would you mind if I shared my screen really quick?
I would love it if you shared your screen really quick.
I have an absolute nauseating amount of lint on my screen, and I cannot figure out.
Mine looks the same. Yeah, mine's all over the place.
What
Yeah,
about
mine looks just like that.
All right.
Run your formatter. It'll get rid of all of it. If you right click.
Okay.
And go to format.
Format. Did
Up.
Here.
Like, yeah. So like prettier, I think, is the one that gets rid of all of it for you. It's all just formatting. It's like ESLint.
Yeah.
Use your keyboard shortcuts. What's the keyboard shortcut for auto formatter?
Good question.
Shift F.
Shift Alt F.
Do you have prettier installed?
I have no idea.
That's the
I
one.
know that I did this when we were doing our Pokemon TypeScript, and I am sorely regretting whatever I did to cause this.
Do control period.
Control period.
And then fix all prettier problems.
Oh wait, okay.
Do all.
Yeah. All right, so fix all.
Hey!
Yeah, I don't like that. How do I uninstall that? Like the prettier thing.
No, like prettier is probably part of the assignment. There's probably a formatting file in there. You should get prettier installed. We can handle that another time. But yeah. That's
okay, no worries.
That's the trick to that.
Thanks. That was driving me nuts. It's really hard to look at all that.
It's supposed to, so that you go and fix it.
Fair enough.
All right. Other questions so far? So these are saying I'm going to have 3 properties. They're going to be of this type.
So if you didn't declare with like 2 through 4, would this still put the side 1, 2, 3 on it?
Yeah, I totally would. Or maybe not. Ah, yeah, there you go. I think you can get away with that in JavaScript, but not TypeScript. But yeah, it's saying, hey, I don't have a side 1, side 2, side 3 property. So that's how you let it know that these properties exist. Now, you can also do this. You could say like side 1 equals 0. We could do that instead. It really depends on like on whether or not you should, like, you're going to be given these things in a constructor, or whether you're not, but they should still have an initial value. If you're being given the stuff in a constructor, don't waste time assigning it first. Just tell it what the type is and let the constructor do the rest. If you're not going to be given a value, but it is part of the initial state of the thing, then just assign it up there.
And so on lines 10 through 12,
Mm-hmm.
if we could just really quickly, the left side of the equals operator, this dot side 1 is referring to line 2.
Yes.
And then equals side 1 is referring to line 6, side 1 number. And it goes down that list respectively.
Bingo.
Awesome. Okay, that's
Yep.
making more sense.
All of these are the arguments that you were given down here.
Okay.
They don't become part of the state of the object until you assign them to the state of the object with this. And like, we don't want them to. Like, we don't even know if we're being given valid stuff until we do this test. Once we do this little test here, we go, oh, okay, cool. Well, at least they're valid numbers. Now I can safely assign them to the state of the object.
I did letters and sides because that part kept confusing me.
The which?
I did letters
Ah.
when in my class, and I did sides in my constructor because it was throwing me off.
Yeah, and like this particular convention of naming this in the as the parameter and then naming the exact same thing as the instance variable, super common. That's normal in JavaScript, that's normal in Ruby, that's normal in JavaScript or in Java. Like most folks will expect that and then the state that it maps up to be called the same thing. Other questions so far? All right, let's take a look back at that test. So this is saying if it makes a new triangle and then tries to get its is equilateral property, it expects that to be true. Okay. So what you could be forgiven for thinking you should do here is have a property called is equilateral. And then like doing whatever calculation you need to do over here to set that to true or false. Don't do that because remember, all of these are stateful. They could change over time. This constructor gets called exactly one time when the object gets made the first time. So is equilateral is dependent on this state. So that means it needs to get calculated when it gets called. This is where getters come in. If you do get is equilateral, you can make that a method, and that's going to get called with, if you treat it like a property, it just invokes the method. It's kind of cool. So doing dot is equilateral doesn't actually give you a property. It actually calls that method and then gives you the return value of it. Sort of cool. So what we want to say is like is equilateral should return whether or not side 1. Actually, let's do this. Since this is expecting this to be true, we can be a little bit coy with it just to see if we can get the test to pass by just returning true. And we have a passing test. All right, cool enough. So it isn't until we like keep going that we get a failing test. And we go, okay, So I got the first one to work. The second one, all right, so I can't hard code true as the response. So then the next thing you do is what we call a naive solution. A naive solution is, all right, is there some, like an obvious thing? It might not catch every single case, but whatever, you give it a shot. So I want to check whether or not this dot side 1 is the same as this dot side 2 is the same as this dot side 3. Oh, it didn't like that I tried to chain those. Oh, and it wants to see, oh yeah, like, come on, man. All right, well, now my formatter's fighting me. What if I... do this? There we go. All right, so if side 1 is the same as side 2 and side 1 is the same as side 3, let's see if that does it. Hey, beautiful. So, does this hold up? If I do all of this stuff in equilateral triangle, is there anything that's still mad at me? All 0 sides is not a triangle. All right, so I have that throwing an error. It doesn't like that. So let's see what it's expecting. So sides have to be positive, or all 0 sides is not a triangle is the name of the test. Okay, so it doesn't want that to throw an error. It just wants it to return false. So that's going to be, I could put that in here. Return false. Oh, and that kind of makes sense to do it in the method also, because since these are stateful, they could start out as all positive numbers and then eventually get changed to 0 or negative or something like that. All right, what'd that do to our test? Hey, we got passing tests. So now that we have passing tests, it's time to refactor this. Is there a more elegant way to do this? And I think there is, because this would be the case with any of these. I want to check it, like whether or not it is a triangle. So maybe I have like another one that's like is triangle that does this. And anytime you find yourself doing a big condition like this and then returning true or false, just return the actual expression. So that determines whether or not something is a triangle. So now we can say this dot is triangle and if these tests still pass, oop, not so much. All right, now I got 3 failing tests. It's because these need to be opposite. I want them to be greater than 0. And I want those conditions to be ands instead of ors. So I'm not seeing whether or not I should throw an error. I'm seeing whether or not I should actually do the thing. Now we got passing tests. And it's refactored. Looks all pretty and elegant. Pause, catch up, ask me some questions. No one has questions? Everyone understands how that getter works?
Still catching up real quick.
Yeah, I'm
Alright.
just trying to catch up. I'm
Is-
way behind.
All
Yeah, you were
right.
flying through that. I'll ask the annoying questions. Is it the case here that the getter is really working as a method creator? Because previously I was trying to think that the constructor is how we make our methods and our functions within the class, but now we're using Git and it has all that great function format.
So, okay, the constructor's job is just to set the initial state. It doesn't do any other like behavior kinds of stuff. All it does is set up whatever your initial state is. We could keep these as methods. So like if we did, they'd probably look something like this. So if I do that, that's like the exact same logic. And I could do something like cute triangle is new triangle 111. And then I could say cute triangle dot get is triangle. And that's going to be true. And I could also say is triangle and not invoke it. That's the difference between those. They otherwise work the exact same way. But a getter method doesn't need to be invoked. You can treat it just like a property.
Okay.
But the cool thing about it is that unlike a property, it's calculated. Because if I tried to do this as like the same logic, just as a property, like is triangle equals all that. Aside from like the fact that you can't use this outside of a method, can anybody tell me why that would be a problem? Has to do with when that gets calculated, evaluated.
You haven't assigned a type?
Not quite.
Just scope.
It's before this.side one. Like when it's called.
None of those things. When would this get evaluated, even if the syntax was okay?
Is it an
Is it after?
initialization?
Is it supposed to be after the constructor?
So it would technically be before the constructor.
Oh, okay.
How many times?
Once?
Once. Even if these change. 'Cause remember, they're stateful. I can do stuff like cute triangle equals. So like both of those come back true. Say I'm not doing that. I'm just relying on this thing up here. I make a valid triangle. I say cute triangle is triangle. True. And then I set cute triangles side 1 to -42. Now it's no longer a valid triangle. That property doesn't recalculate or anything. So if I put it in a method, when I invoke that, it recalculates every time that method gets called. So it's based on whatever the current state of the triangle is. And then if I just make it a getter like that, I don't need to invoke it. Because I would never invoke a getter with an argument. That doesn't make any sense. You're getting a value. You're not giving it anything. But it allows this to be a calculation rather than just a static value.
So I made it part of my export class, which I'm thinking was probably not the correct way, but I didn't declare zeros either, and just included in my constructor. Is there a reason why that wouldn't be preferred?
Yes, because if you do, your constructor runs exactly one time. It's whenever new gets called. And the problem with that is that these can change. And so if you do that, like, say you have like a is valid or is triangle up here, and it's a Boolean, and then you do something like if then is triangle is true, else it's false. Or if we did this like the way that I was just telling you about, where if that's all we're doing inside of here, then just assign it directly. Say like this dot.
Well, that's what I did.
Is triangle equals that. So who can tell me what the problem with doing that is?
It'll only be assigned when it's constructed.
Yep.
And it won't be able to be changed.
Even
though the sides may change.
Yes. So if I do that and I make a new triangle, is triangle is going to be true. And then if I change one of the sides, it's still true because this only runs because of the new keyword. Remember, these are state. State means that it can change. That checks the initial state. It doesn't check the state every single time one of those changes, though.
So if you were to create a new object, it would check it. But if you were ever to change the object that was created, it would have no checks and balances.
100%. Versus with that, this gets recalculated every single time you look at it. So when I'm trying to see whether or not something is equilateral, it first checks to see if it is currently a valid triangle. Not that it was initialized to be a valid triangle, not that it has always been a valid triangle, but whether or not it is currently a valid triangle.
And your order of operations here within the get method is going to matter for that. You'd want the is triangle to always be first, so it checks that first and then runs through your system.
Yeah, and that's just because like that's fewer calculations. Like there's no need to do these comparisons if it's not even a triangle.
It's not a triangle.
But otherwise, you could reorder these and it'd be fine.
Great.
So I just found a loophole that allowed to pass, but wasn't necessarily the right way.
Correct.
Okay, that's why I'm in this class.
Indeed.
So Kyle, a lot of what we've been doing in the program, and we haven't heard it reiterated a lot in OOP, is where is our input and where is our output?
Ah.
Is it okay for us to sit here and think, okay, so I've created a constructor and then I'm going to have all these get methods. The constructor is going to be my input for these get methods. Awesome.
Ding, ding, ding.
Okay, cool.
So this is the input. This is the initial input. I can still change that. That's also input if I reassign one of those values.
A dynamic input almost.
Right. So like that's it the first time. That's that. This is output. This is output. This is output. They're split up. The same way that, I guess we didn't do this so much in procedural programming. So like new idea, you don't get all the input at the same time. Initial input, later input. Output, output.
Very cool.
Other questions? Still got some passing tests. Okay, so starting from here, I want you to see if you can get the isosceles triangle working. So start by taking your describe only out of that and moving it down to here. I'd also recommend putting your it only onto that one. See that you got a failing test. Start trying to get that to pass. I'll leave this up. Start with 6 minutes. Go for it.
Hardest part is spelling isosceles.
pencils down. Ask me some questions. What was hard about that?
I was able to put it in for one of the first tests, and I really just need to create like this one. You have to do multiple tests on it because side one can equal side two, and then side one not equal to side three. But then you have to do the instance also of side one not equal to side two, and side one equal to side three. But then you also have to do another instance where all three sides are still equal because it could also be equilateral. So you've got to throw in it's right because you have multiple statements there. So
yeah, totally. So let's walk through them one at a time. Okay, so it's making a 3, 4, 4 triangle. Well, first, let's get the thing to not be mad at us anymore. Let's just make a is isosceles method. Getter, yes. All right, so I just sort of lied to get the first test passing. Let's add a second one in. Okay. Are all these true? That's less helpful. In that case, if all of those are going to be true and all of those are going to pass my hard coding, I want to see one where it's not. So I'm going to force that first one and this one just so I can get my hard-coded true to be false. Because if we want to always be going from red to green, if we're just not getting any feedback at all, that's turning on hard mode. If we're green all the time, we're not really doing anything. If we're red all the time, we're not making progress. So we want to go from red to green, red to green, red to green. So we've forced ourselves into red. And it says no sides are equal. Okay. This is all sides are equal. So what if I just said not this is equilateral? That probably gets me some of the way there. All right, didn't do that one. So, because that one is not equilateral, because it's 2, 3, 4. And so that's returning true right now, but that's actually false. Okay, so starting from here, I want it's not equilateral and this dot side 1 is greater than this dot side 2, maybe? Let's see what that does. Nope. What about the other way around? Nope.
Probably there's also a function that says equilateral triangles are also isosceles.
Oh, that probably hurts a little bit. So, all right, not making progress there. Let's go back to this first one. Okay, this says the last two sides are equal. So returns that the first side is not equal to the second side, but the second side is equal to the third side. I'll bet that'll pass. So it returns this dot side 1 does not equal this dot side 2, and this dot side 2 does equal this dot side 3. Let's see if that gets the test passing. Does. So give me another one. It says, okay, the first two sides are equal. All right. What if I kind of isolate this one off and say, or this dot, what was the language of the test? The first two sides are equal. This dot side 1 is equal to this dot side 2. And this dot side 2 is not equal to this dot side 3. I got 2 passing tests. So does this logic continue to hold up as I go down? Okay, next one. First and last sides. So I can probably do sort of the same kind of thing. But first side is the same as the last side, but the first side is not the same as the second side. Passing. Okay, does that keep working all the way down? Equilateral triangles are also isosceles. So I already have a test for whether or not something is equilateral. So I could say, if this dot is equilateral, or any of those, passes.
So while you're doing this, since an equilateral triangle is an isosceles triangle, aren't the instances where it's like this one equals this one, but not this one? Aren't you just overriding that by asking if it's equilateral?
No, because of short circuiting. If it's equilateral, it doesn't check any of the rest of this. So that means that if it's getting to these, that means it wasn't equilateral.
But then why do you still look to see if it's not equal to one side? I might not be explaining this right, but it seems like you're doing more work than you need to.
Oh, I almost definitely am. This is the process. Do not try to over-optimize your solutions too early. This is part of the red-green refactor process. If you try to do an elegant solution up front, you're going to work yourself into a corner and make this way more difficult. So what we want to do is get this green, and then once it's green, we want to clean it up and look for that kind of duplication and stuff. And since we'll have green tests, we'll know exactly if and when we did something that actually broke the whole thing. Does that make sense?
Yeah.
Excellent. So we're in pretty good shape so far. We got green tests. What about here? Failing. First triangle inequality violation.
It's another one of the special rules.
Is triangle first too?
Ah. So if I do that, oop, that didn't do it. Does it, is that in the README?
Yeah, you have to add a rule to is triangle. The sum of two sides must be greater than the third side.
Okay. So that's going to be an and, because for something to be a triangle, it needs to fulfill that rule and the other rule. So we'll say that's going to be the rule that we're figuring out, and everything else sort of chains off of that. So we say this dot side 1 plus this dot side 2 is greater than this dot side 3. Oops. Or this dot side 2 plus this dot side 3 is greater than this dot side 1. Or this dot side 3 plus this dot side 1 is greater than this dot side 2. Is that the rule? Something like that? think so.
I think it's an and. I'm not sure if it has to be or not, but at least that's how I read.
Oh, I
how
think
the
you're
README.
right.
Yeah.
So yeah, all of those need to be true, and this dot is triangle needs to be true. Oop, not quite. So let's look at this rule again. The sum of any two sides must be greater than or equal to the length of the third side. So that's actually this. All right, so let's make sure I got the logic on that okay. For something to be a triangle, oh, you know what? Even better. This is a great opportunity to abstract that out into a method. Where it's like, conforms to side law. Because like this is getting like nonsensical at this point. So I can take that and do something like this. Okay, so now this should be what I had before, but now I can say this dot conforms to side law and whatever else. Okay, so let's make sure this logic checks out. 1 and 2 is greater than or equal to 3. 2 and 3 is greater than 1. 3 and 1 is greater than or equal to 2. Does that track? I think that tracks. So for something to be a triangle, it has the side law and does those three things. So then to figure out if something is equilateral, that logic isn't quite right. So this would be is triangle and there we go. Passing test. It's a miracle. So we check that it's a triangle as a precondition. Hey, remember preconditions with short circuiting? And then everything else is wrapped in that next condition. If it's equilateral, automatically isosceles. Otherwise, we check any of those three things. And then we're back in green. Does it keep holding true? Keeps
I'm
holding
sorry to
true.
interrupt.
Yeah.
I have a question.
Hit me.
When I was doing this on my own on Saturday, a couple days ago, I was wondering, does the parentheses matter?
Very much so.
Like in your statements?
So
I mean, conditional. Sorry.
yes. So what they do is they group stuff. So let's like kind of exaggerate this a little bit. I'm gonna indent these way in. All right, so exaggerating it a little bit. The entire thing is wrapped in parentheses. That's just the formatter doing that. And it makes it so that I can safely do this thing on the next line after the return. But this whole thing is effectively one condition. So I want to make sure that it's a triangle first. And then if it is, my precondition has been met so that I can check any of the rest of this. But all of the rest of this stuff, it's not at the same level of this. It's all kind of like dependent on it. So I can force this to effectively be is a triangle and follows all the isosceles rules. And so then within these rules, it can either be an equilateral triangle or it can meet all of these things. But by wrapping all of these in parentheses like this, it keeps all of this Boolean logic from leaking out into any of this other stuff. Because we can get in kind of weird situations where like the precedence of the operator matters, where like the same stuff, if we flip it around, like means something completely different. So rather than like get all obsessed with how the rules for precedence work on that, just aggressively wrap stuff in parentheses to show how these statements should be grouped together and like considered one unit. And then after that, just use your formatter to do all the rest of it.
Okay. All right. Yeah, because my formatters were putting parentheses in like random spots. So then I had to like put it everywhere that I thought, and then it
totally. And like it's not sometimes you need to be a little bit more aggressive with parentheses than you would otherwise because your formatter is trying to be too helpful.
Okay, thank you.
That's normal.
Can you scroll up a little bit on your screen?
Totally. Let me clear all these out because we're passing now. All right, cool. So I see fields of green.
Thank you.
So here is an outstanding opportunity to talk about access modifiers. Conforms to side law is not something that should exist outside of this class. You would never do something like const sum triangle equals new triangle 1, 2, 3, and then do, hey, does this conform to the side law? All we care about is like whether or not it's a triangle, and really not even that. We care about like whether or not it's equilateral or isosceles. So all this stuff that we would not want somebody who's just using our triangle class to use, we can mark as private. And as soon as we do that, it goes, nice try, buckaroo. Same thing with the like is triangle function. That only gets called by other methods inside of this class, so make it private. For that matter, we probably don't want, well, maybe we do. I say if we make these private, we can, and we can still check whether or not a triangle is equilateral or isosceles or whatever. We still get passing tests, but now we can't change the sides after we instantiate it, because that's the only way to get the state in. Maybe that's what we want. But that's what's being communicated by that. Privacy works like const. You want to default to have something being as narrow as possible and then open it up as needed. But it's like really heavily driven by what should the interface of this triangle be. Speaking of which, can I put these both in the same namespace? No, I can't. So if I say implements I triangle, the I stands for interface, I can say what things should be publicly accessible on this. Well, it should have an is equilateral. That's a Boolean. And it should have an is isosceles. That's a Boolean. And cool. So that means if I'm trying to write something that works with triangles, I don't need to look at all this shit that I wrote. Like, how do I know what things I can be guaranteed anything that is a triangle is going to implement? I can just look at the interface. I go, all right, I can depend on those two things existing. This stuff like conforms to side law. Oh, maybe I changed the name to conform to side law. All right. Didn't change my interface at all. So none of the code that's programming to this interface needs to change. That's abstraction.
Just to restate it, so like is triangle, there's no reason for anybody outside using the triangle interface to call that, because the point of it is because it wouldn't even make a triangle if that was not true.
Bingo.
Okay.
Well, and it's also like it's being used by these other things. So if you want to find out if something is equilateral or isosceles or whatever, well, there you go. Or maybe you do want to check that it's a valid triangle, but like you want that to be an explicit choice that you make, because as soon as you make something part of the public interface, now you're like other people might decide to use that. Other people on your team, other people in the company. You might have 1,000 people who are depending on an is triangle method now that you can't get rid of. So you want to be like very judicious about what you publish as part of the contract for this thing. But now this is saying, hey, you didn't implement the interface correctly because you made is triangle private. But like this is almost like a cheat sheet of like, all right, what is a triangle guaranteed to have? You're not going to refactor it out. You're not going to change the name. Like, how is it supposed to work? That's what the interface is.
Are get methods hoisted?
Hoisting doesn't make sense in terms of a class. That's one of the reasons that like this isn't just a function body where we can just put random statements in here or call define functions and do all that sort of stuff. And it's confusing because it looks like it's a little bit like that, as these things end in semicolons and what have you. But there's no like concept of order with any of these things. They are all just, it's the same thing as like regular JavaScript objects. The order of those properties like doesn't actually mean anything. They're just all available.
Okay, yeah, my question was geared towards conform to side law being defined on line 27, but called on line 20.
These can be in absolutely any order. It's like saying you have a large blue shirt or you have a blue large shirt. It's the same stuff. You're just describing characteristics of something.
Gotcha, thanks.
Other questions so far?
In what case would it make sense to make something protected? Because I remember reading about that too.
Sure. Rare. So what protected is it cannot be accessed outside of the class. So it kind of works like private. But if something's private, things that inherit from that class also can't do anything with it. They can't see it. They can't mess with it. They can't do any of that sort of stuff. So if they should be able to do that, but still not be used from the outside, that's protected. That's way less common than private or public.
Okay, thank you.
Other questions? Okay, so Blair's comment from earlier, where it was like, might some of this kind of be redundant? I imagine so. And the cool thing is that now that we have all of these passing tests, we can kind of play around with this and get instant feedback on whether or not we broke it. This is the idea that keeping something working is easier than getting it working to begin with. So Blair, you and me are pair programming. What can I get rid of?
Each instance of not equal to.
Okay. So if I get rid of that one, do my tests still pass? My tests still pass. So what about this one? My tests still pass. All right, what about this one? Oops, something I didn't like there. My test still passed.
Why can you get rid of those?
Blair, why can I get rid of
Fine.
those? Go ahead.
So since an isosceles triangle is, since an equilateral triangle is also isosceles, it doesn't really matter if the we don't have to figure that out since we already have the is equilateral. All we need to figure out is if it's a triangle and if side 1 equals side 2 or side 2 equals side 3 or side 1 equals side 3. You don't have to figure out if one of them isn't equal because that's just not important.
It was covered by this. All three of these conditions assume that it was not equilateral.
If we get rid of the not statements, do we need the this is equilateral anymore?
No.
Right? Because it could be any of those instances can be equilateral also.
Yep.
All right. Let's see if it matters. Still passing.
It's just with how triangles work. It would be similar exercise if you're trying to see if a square is a rectangle. It works the same way.
Beautiful. But see, okay, so that feedback loop, that's the entire point of pushing out that kind of refactoring work to the end. Because like the way that we got it working was very brute force, throwing it all out there. It's got some redundancy, whatever. Can we get it green? Once it's green, we can just try stuff and see if it broke. That's faster.
Kyle, I still have 2 failing tests for second triangle inequality and third triangle inequality, but all my other tests are passing, which is confusing me.
Does your conform to side law sort of thing look like mine?
I have an extra set of parentheses in there, but it's identical otherwise.
Where's your extra set of parentheses?
It was around each, so this dot side 1 plus this dot side 2 is greater than or equal to this dot side 3. That all was in parentheses.
Like that?
Yes, exactly like that. So each statement was wrapped in parentheses like that. I just removed them now.
All right, last thing we're going to do before lunch. Go ahead and screen share. Let's take a look.
All right. Yeah, because I just updated that and it's still failing.
All right, let me see your failing test.
So here's all the tests are passing, and I'm failing second and third triangle.
Okay.
It's expecting false, but it's receiving true.
All right. Keep scrolling down. Keep going. All right, run your tests. All right. Put it in watch mode. So press up, and then space, and then dash dash, and then space. Oop.
Oh.
And then dash dash watch all. All A is capitalized in all. There you go. Okay, so
I see what it is.
what is
Hit
it?
me.
If you go to under your get is isosceles, you wanted to check, is it a triangle, and on all of those below. So all of those have to be within their own parentheses. Mine did the same thing. The linter, when you did a reformat, it keeps trying to move the parenthesis above the this is triangle, and there has to be one below it. Just before the first this dot side one, there has to be a parenthesis. The top one has to
Right.
be
Because all
there.
three of those are one condition.
You want those all in between one condition. And mine did the same thing. It took it off. And if you do
So
like
do
control,
you mean like this essentially?
yes. But when you do control F, the linter is going to try to take it off.
Let me see.
But you can also get rid of each group of parentheses.
Yeah. So I can get rid of these now, right?
Let me see what your linter does.
Oh, well, hey, look at that. They all pass.
Yeah, but run your linter.
Control F.
Whatever your auto formatter thing is.
Oh, I disabled prettier because it was still linting me to death, and I just format on save. So when I save, this is it.
Okay, so this time it worked, but that's what it was. It was that extra parenthesis within that area.
And it's weird because it didn't give me that grief for is scaling. Like, it just did that here. Like, you see, it's the same concept that you told me to add one here. Suddenly my test passed. I don't have one down here, but these were working, I guess, fine. I don't know.
Well, I mean, it's a different problem. But also on 49, 50, and 51, exclamation point 2 equals.
2 equals. All right.
Otherwise, very nice. All right. Any last questions before we break for lunch?
Thank you guys, by the way.
Of course. Awesome. Is the OO picture starting to get a little clearer? Seeing some nods?
Yes, it is. Thank you.
Excellent. So like I said, it's not a series of like, got it things. It's fuzzy, clearer. That's how understanding OO works. All right, so let's do some more after lunch. See you then.